Hello, dear students. Once again, welcome back. Hope you all are doing well. Dear students, as we all know that nowadays we all are staying in our home. So this is the time which is very important for you towards your studies. Please utilize this time for your studies. Now, those students who are having the NCERT book with them, they can go through the chapter and just understand the concept, just go through the chapter in details and see all the topics and just read it once or twice. And those students who are not having the NCERT books, they can download it from the internet. So just utilize your time towards your studies. That's what I want to say. Now let's start today's topic. So in the previous class, we have learned about the solubility of solids in liquid and what are the factors on which the solubility depends. And in today's topic, we are going to learn about the solubility in liquid. So this is again very important topic. The last class we have discussed the solubility of solids in liquid, and in today's class we are going to see the solubility of gases in liquids. So we all know that gases do dissolve in liquids. So almost all the gases are soluble in water through different extent. Now we know that the existence of aquatic life in lakes, rivers and sea, it is mainly due to the dissolution of oxygen gas of air into it in the water. Okay, so some gases are also soluble in the solvents like ethyl alcohol, benzene, etc. So solubility of gases in liquid is also expressed in terms of molarity or in terms of mole fraction. Okay, now see, it's given here. The solubility of gases in liquid solvent increases with increase in the mass. Now the reason is that the larger molecules have stronger dispersion forces. Okay, now this is the basic introduction of solubility of gases in liquids. Now we are going to see now what are the factors on which the solubility of gases in liquid depends. Okay, now the first and the most important factor is again the nature of gas and the solvent. So gases like hydrogen, oxygen and nitrogen, they dissolve in water to a very smaller extent, whereas some other gases like carbon dioxide, ammonia, etc. are highly soluble. Now why there is a difference in this case? Some gases, they are soluble to a lesser extent, whereas some other gases, they are soluble to higher extent. Now what is the reason behind this? This is mainly due to the chemical similarity between the gases and the solvent in which the particular gas is being dissolved. Okay, so if there is a chemical similarity between the gases and the solvent, it is easily soluble. And if there is a difference in the chemical similarity, if they are not similar to each other or their properties varied, so there is a lesser solubility of the gases in liquid. So this is the first point. Now the second thing is the effect of pressure on solubility. Now the effect of pressure on solubility is given by the Henry's law, which is very important for you. Now Henry, he studied the effect of pressure on the solubility of gases in liquid in the year 1803. Now what is this law? This law states that the mass of the gas dissolved in a given volume of a liquid at a particular temperature is directly proportional to the pressure of the gas present in equilibrium with the liquid. Okay, now in simple words we can say that the mass of the gas dissolved in a given liquid is directly proportional to the pressure of the gas present in the liquid. Or we can say that M is directly proportional to P, where M is the mass of the gas and P is the pressure of the gas. Or in order to remove the proportionality sign, we have to use some constant. Here we have used M is equal to K into P, where M is the mass of the gas dissolved in a unit volume of solvent and P is the pressure of the gas in equilibrium with the solvent, and K, which is very important, is the constant of proportionality whose value depends on the nature of the gas. Okay, so this is what we call as Henry's law. So this is the effect of pressure on solubility of a gas. Okay. Now the next is your effect of temperature on the solubility of gas. Now what is the effect of temperature on solubility of gas? See, in the previous class we have seen that the effect of temperature on the solubility of solid. Now in different gases it is different. In case of solid it is different for different gas, different solids. Now in case of gases, what happened? The solubility of gas generally decreases with increase in temperature. Whereas for solid we have seen that generally it increases with increase in temperature. But this is just reverse in case of gases. Generally the solubility of gases in given solvent is decreases with increase in the temperature. Now why this happens? Okay. We know that heating the solution of a gas, some gas is usually expelled out of the solution. Now if we are heating a particular solution containing some gas, what happens? The gas usually expelled out of it. As a result, we say that the solubility decreases. Now the dissolution of gas in a liquid is an exothermic process. Okay, see, it's given here in the reaction that gas plus solvent gives solution plus heat, because the solubility of a gas in a given solvent is an exothermic process. So heat is released in this process. See, this reaction is in the state of equilibrium. Now if you are applying the Le-Chatelier's principle into it, now it is evident that on increasing the temperature, the equilibrium will shift in which direction? Okay, it is shifted in the backward direction. Now if it is shifted in the backward direction, the solubility will definitely, yes, it decreases. So this is the effect of Le-Chatelier's principle. So the solubility of gases, we can say that the solubility of the gases decreases with increase in temperature. Now this is the effect of temperature. Okay. Now see the application of Henry's law. Now the Henry's law application, it has some important application in our day-to-day life. Let us see one by one. So it's given here, the first one, in the production of carbonated beverages. So we all have seen that in our day-to-day life we are drinking some carbonated beverages like Pepsi, Coca-Cola, etc. Now what happens in this case, when we are opening the bottle of this carbonated drinks, usually some gas coming out of it. Now what is the gas? Yes, that is nothing but the carbon dioxide. Now what happened in this case? To increase the solubility of carbon dioxide in soft drinks, these bottles are sealed under a very high pressure. Okay. Now when these bottles are open to the air, and when it come out in contact of the air, the partial pressure of the carbon dioxide above this solution decreases. So as a result of it, what happens? The solubility will decreases because the gas comes out in contact with the air. Okay, as a result of which the pressure of the partial pressure of CO2 above this solution decreases, and it comes out of it in the form of CO2 bubbles, and hence the solubility decreases. Now the second point is given here for the climbers or the people living in the higher altitude. So those people who are staying in the higher altitude, what happens there? The partial pressure of oxygen is less at the ground level. So as a result of low concentration of oxygen in the blood and tissue of the people, those who are living in the higher altitudes. And same thing is happen in case of the people, those who are climbing the mountains there. So what happens? They feel sick and they are unable to think properly because of the lesser amount of oxygen in their blood and tissue. So this is the key. The third point is in the function of lungs also. Okay, so these are some important application of Henry's law. Okay, so what we have discussed till now, the solubility of gases in liquid solvent. So generally the solubility of gases in liquid, it depends on three factors: nature of the gas and the solvent, effect of temperature, and effect of pressure. Now, effect of temperature is what? The solubility of gases generally decreases with increase in temperature. Why? Because the dissolution of gas in liquid is an exothermic process. So when we are heating it, the reaction will shift in the backward direction, and thus the solubility decreases. Similarly, the effect of pressure, which is given by a very important law, it's called as Henry's law, which states that the mass of the gas dissolved in a given volume of liquid is directly proportional to the pressure of the gas above the liquid. More the pressure of the gas, more will be the solubility of the gas. Okay, so this is so the next thing is very important again, ways of expressing concentration solution. Now the concentration of a solution is the amount of solute dissolved in a given or in a known amount of solvent. So what is this concentration term? The concentration is defined as the amount of solute dissolved in a given amount of solvent. Okay, so here what are the different ways to express the concentration of solution, or what are the different ways to expressing the amount of solute dissolved in a given solvent? So here are the different ways. Now this particular topic you have also learned in your previous class, that is class 11 in the first chapter. So here it is. The first one is the mass percentage. So mass percentage is defined as the mass of the solution divided by the total mass of the solution into 100 parts per million. Now it is nothing but it's equal to the mass of the solution divided by the total mass of the solution into 10 to the power 6 parts per billion. It is defined as the mass of a component in the solution divided by total mass of the solution into 10 to the power 9. So this A is the amount of solute or component A. Mole fraction X, mole fraction of a component of a solution, say component A is written as XA is equal to moles of A by the total moles in the solution. Or we can say mole fraction of a constituent is the fraction obtained by dividing the number of moles of that constituent by the total number of moles of all the constituent present in the solution. Now suppose if we want to find out the mole fraction of X1, so it is equal to N1 by N1 plus N2. Similarly, if we want to find out the mole fraction of X2, that is solute, which is equal to N2 by N1 plus N2, where N2 and N1 is the number of moles of the particular component. Okay, so some other concentration terms are also given here. The very important one is the molarity. Now molarity is nothing but is the number of moles of solute dissolved in 1 liter of a solution. That is, we can also write it like this: moles of solute by volume of solution in molar in liter. Now here it is one important thing is given, that molarity is depend on the temperature, whereas molality is independent of the temperature. Okay, before discussing this, let us see what is molality. Now molality is the number of moles of solute dissolved in 1 kg of the solvent or 1000 gram of the solvent. Or we can write it like this also: moles of solute by mass of solvent in kg. Now what is the effect of temperature on molarity and molality? This is very important question. Many times this question comes in your exams also, in class 12 board exam. Now effect of temperature on molarity and molality. See, molarity is the number of moles of solute by volume in liter. Okay, whereas the molality is the moles of solute by mass of the solvent in kg. So molarity depends on temperature because volume can be changed, but mass of the solvent remains the same. So we can write that molarity depends on temperature, where molality is independent of it. So if we change the volume, molarity also changes, whereas the molality remains same because mass of the solvent remain fixed. The next one is the normality. It is defined as the gram equivalent of the solute in 1 liter of solution. Or we can write it like this: gram equivalent. What is this gram equivalent? Gram equivalent of the solute is equal to the molecular weight by the N factor. Okay, here you have to write the molecular weight of the given substance and N factor. Now N factor is the number of electrons that are being lost or gained during the reaction. Okay, so this is all about for today's topic. If you are having any doubt related to this topic, you can ask me in the comment section or you can give your feedback. I hope this topic is now clear to you.